For my final project, I wanted to do data depends with fuzzy matching. Data depends add value that enable exploratory data analysis and enhance predictive models. Some examples are appending a credit score, appending lat long so you can calculate distance to a location. If you have a KFC, how many people are within 3 miles? If you have a bank, where does your normal customer live relative to your branch? Or looking at home sales, how many home sales and what's the average price per square foot in the area? For this project, a lot of times you have data hygiene issues, so I wanted to incorporate 2 different fuzzy matching formulas to help me really evaluate whether something is or isn't a match. The Jar-Winkler is good at looking at a substring similarity. Is Rob similar to Robert? Yes, that will have a very high probability of being similar, whereas Robert versus William will have a very low probability. This is very good for identifying misspellings and abbreviations in addresses and other alphanumeric data. Second fuzzy matching formula is Livingston distance, which is really good at telling you how many swaps. Is it 93301 or is it 39301? That takes 1 swap to convert one to the other. It's very good dealing with numeric data such as zip and phone number. The data I used for this is a zip geo file from everything by zip code and a address file I grabbed off a GitHub site. With this information, I said, okay, let's look at how it works in a perfect world. And you see we get all 50 results. Sorry, let me back up, tell you what the geo data looks like. I pulled it all in, and then I broke it into racial demographic, zip, geolocation information such as lat long, as well as MSA. Is it part of the New York metropolitan statistical area, etc.? And then I also had age demographic data. With that, I went through, like I said, did the initial match, everything's perfect, it looks great. But in the real world, you have data hygiene, so a lot of times you get results like this, where it says this zip code is this place. Brooklyn, New York is very different than Buena Vista, Colorado, but the zip code matches exactly. So you can't use that and believe it all the time. If we just go, how many individuals, we try and match it with the Jar-Winkler to within that state based off the similarity of the city, you see we get all of these. Some horrible matches, some good matches, but we have way too many matches in Brooklyn, New York. We need a way to differentiate these. So we can add the Livingston distance, and now by adding the Livingston distance and putting a restriction on the Jar-Winkler similarity, saying we want them to be similar, we can identify just a selected subset, and we can pick the best match out of that subset. With that information, we can then say, this is the match that we want. And you notice it's Brooklyn, New York, and it only takes 1 swap. The real zip is 11211 as opposed to 81211. That's 1 swap in the zip code to get us what we want. Putting this all together, we can basically grab everything that is an exact match and passes the match criteria. We can then take everything that didn't match and grab the best match that we can find. We can also go through and evaluate the match. Is it a perfect match, or did we have to correct the zip? Once we have done all of that, we can then go through and get a final file.